It is week 2, day 2. So you're going to click on day 2. Make sure you take your attendance. Our goal is today that students will solve linear equations and inequalities with one variable. This video will be posted in this box. Your assignment will be here. Go ahead and let's take a look at some of the things that we're going to do. So one of the things that we will be working on today is inequalities, and so this is not my style. X over here. Oh my gosh, they cubed X. So it's a joke. It's not that funny. All right, so we're going to work on laws of exponents. So this is saying that if they have the same base, we can simply add them. So when I look at these ones here, they have the same base. What I can do is I can just change this to where it says 4 as the base, and then 2 plus 4 is 6. So that's what the first one's saying. The second one's saying that if we have it like this, we can separate them. So like this here, there's a 1 there and there's a 1 there. What I'm going to do is multiply the 2 times the 1 there and get 3 to the second. And then I'm going to get p to the second. And then this is saying that if we have a exponent on the outside, we just multiply them. So like this one here for number 3, I'm going to multiply this. 2 stays the same. 2 times 3 is 6. So, and then this one here says anything with a 0 power automatically means 1. So, for example, except for if x is 0. So like right here, this m to the 0, it automatically means 1. And we'll talk about that in a second. And then anything to a negative number, we flip to the opposite side. So see how this is this here? So we can add these because they have the same base. So we're going to get 3 with a negative 7. But because it has a negative, we want our exponent to be positive. What you're going to do is you're going to put the number, this is going to be equal to 1. And then the base flips to the bottom of a fraction, and it becomes positive 7. Now, if it was negative on the bottom, it would go back to being positive 3 over 7 over 1. We'll take a look at some examples here in a minute. This is saying that if it has the same base and we're on top of the fraction, we can subtract. So, for example, here, these are the same. This is going to become 2, and then 3 minus 2 is 1. Same thing here. This is going to become negative x. 4 minus 2 is 2. This one we're going to multiply out. Negative 3 times both of those. So it's going to become a to the negative 6 and b to the negative 12. Well, we want our exponents to be positive, so we're going to take this and it's going to become 1 over a to the 6th and b to the 12th. They just go to the opposite side of a fraction. These here is pretty cool. What you do is you take the regular numbers and you multiply them together. 2 times 3 is negative 6. And then p is the same, so we keep the p. And then since we're just multiplying, we can add 2 and 4 together and we get p to the 6th. For this one here, it's the same thing. We're going to do 3 times 4 and get 12. X, we can add these. So this becomes x to the 8th. And then y becomes x to the 7th. Same thing here. 3 times negative 3 is negative 9. I always like to put mine in alphabetical order, so I go m next. M and 4 become 4 plus 0 is 4. And then if there's not an exponent written there, we got to assume that it's a 1. So n stays the same, and then 1 plus 4 is 5. Exponents are kind of hard. You might have to look those rules up every so often. So this one says which expressions are equivalent. You would just simply go 4 times 2 makes this 5 to the 8th. And then times 5 to the 5th can come up. And then they have the same base, so 5 stays the same. 8 plus 5 is 13. And so we know that it is B. For this one here, it says Jude incorrectly simplified the expression 1/2 x, 1/2 x, 1/2 to the third. So what they're doing here is that this is not an x, this is a multiplication sign. So let's change this to a dot to make it a little bit more clearer. So this is a dot, it's not a multiplication sign. So this has a 1 here, even though we don't show it. Remember, in math, if it's not written there, it's a 1. So what we should have done is we should have kept the base, and then we should have added the exponents. So 2 plus 1 plus 3 would make this 1/2 to the 6th. And then each one of these have a 1. So this is actually 1 to the 6th over 2 to the 6th. We don't need the 8. We shouldn't have done that yet. So then when we go to do this, you could write, well, 1 times everything is going to be 1. So 1's going to stay the same. And then you could go to your calculator and you could do 2 to the 6th power is 64. And then, so that's the mistake she made, is that she multiplied the bases and shouldn't have. She multiplied the bases and should not have. And then we already correctly simplified it over here. A lot of times, in order to figure out part A, you got to do that first. So it says which expressions are equivalent to this here. So let's do it. It says this would be 5 times -2. So this would be 5 to the -10th. And then times 5 to the 4th. We can add those. 5 to the -6th. So that's an answer. And then we move negative exponents to the bottom side of a fraction. So this should become 1 over 5 to the 6th. So this is an answer. And so this one, if we checked, these would become 5 to the -6. So we're checking for equivalency. So this one is an answer. That one's not. This one's not. And then if you think about this, we would subtract. So this would become 2 minus 5. So this would become 5 to the -6. So this one is as well. Exponents are hard. Take your time. Look up the rules. You may even have to Google some of these. Consider the expression 4 to the 5th. Write 3 other equivalent expressions using at least 2 different properties. So what this is really asking you to do is you have 4 to the 2nd times 4 to the 3rd. So that's one way to do it. You could do 4 to the 1st with the 5 here. That would also work. You could totally do a variety of these. You could do 4 to the 2nd times 4 to the second times 4 to the first. And we don't have to write the first, but as long as you come up being where it's the same as this, there's a bunch of different ones you could write for this. These are not the only three. Now we're going to talk about how to do the equation and inequality. It's really the same steps to solve, except for when you graph. So if you multiply or divide by a negative, you have to flip the sign the opposite direction. And so just one thing you should know is that if it looks like this, it's less than. Looks like this, it's greater than. Looks like this, it's less than or equal to. Look like this, it's greater than or equal to. When you're doing it when you're having to graph it, if it's just less than or greater than, it's an open circle. But if it has the equal to part, it is a closed circle filled in. So when we look at this, we're going to solve this problem here. The first thing we're going to do is subtract 10 on both sides. We get negative 4x to drop down because the 10s cancel. 22 minus 10 is 12. We're then going to divide by negative 4. Divide by negative 4. And then x drops down. 12 divided by negative 4 is negative 3. Now notice there's an equal sign, so we just literally put a dot right there on the negative 3. It's the only thing it could be. On the other hand, for inequality, we do the same steps, right? Those are going to cancel. Negative 4x drops down. The sign is a less than sign, and it's still 12. We divide by a negative 4. The x drops down. Because we divided by a negative, we have to flip the sign the other direction. It's still negative 3. This sign, it's not equal to, so we use a open circle. And we flipped our sign and we shade into, it says x is greater than. Everything this way is greater than negative 3. Same thing on this one. You're going to subtract 10. Subtract 10. You're going to get negative 4x. The sign is greater than or less than. It's 12. You're going to divide by a negative 4. The sign has to flip. X is now less than or equal to negative 3. And because it's equal to, we fill in the circle, and it says less than, and everything this way is less than negative 3. See the difference? Equal sign, just a dot. A less than or greater than sign, open circle, and then it fills which way is true. And then for the equals to sign, it's a closed dot, and it fills which way is true. We're going to skip this one. We're not ready for that yet. Same thing here. 4, 4. So 4 times 1 is 4. 4 times 7 is negative 28. The x comes with it. The greater than sign drops down. Minus 192 comes down. You're going to subtract 4 on both sides. Again, if you need Desmos, you're more than welcome to use it. Negative 28x drops down. The greater than sign drops down. Negative 192 minus 4 is negative 196. Then you're going to divide by negative 28. These cancel. X drops down. The sign flips because you divided by a negative. And then I would just use the calculator because those are pretty big numbers. So negative 196 divided by negative 28 comes out to be 7. And so I would go to 7. I would put an open circle. And then I would shade all the way this way because that's less than 7. You only flip the sign if you're dividing by a negative or multiplying by a negative. After that, you're going to go to Edulastic and you're going to do the assignment that is posted there. Mine's going to look different than yours. Yours will say lesson 4. You click on lesson 4. and you would do that assignment. And so lesson 4 will come up and it will look like this as your assignment. Go through, take your time. You might go back and watch the videos, and then you're going to select which ones are going to be the right ones that fit for that. Same thing here. Same thing here. Cool thing is it's going to show you a hint. Know how to apply the properties of integer exponents, generate whatever. You might have to Google some of these because exponents are hard, but look up the rules. Once you figure out the rules, they become really easy. Same thing here. Same thing here. Same thing here. So, and then this one is an inequality. You're just going to solve it. Notice how it gives you the inequality signs and stuff. So take your time there. And then this is the same thing. You're going to solve the inequality. And then this is a pyramid. Remember that it is 1/3 times the area of the base shape. In this case is length times width times the height of the pyramid. Question 10. Subcompany changes its design from a cone to a sphere. The cone had a height of 1 centimeter, radius of 3. The sphere has a diameter of 3. The amount of extra soap required to change the shape. So you're going to figure out the volume of a cone, and then you're going to figure out the volume of a sphere with these dimensions, and then you're going to figure out what the difference is. Notice it has pi in the answer, so you won't use pi in your formula. The volume for a cone is 1/3 pi, but you're not going to use that, times the radius squared, in this case is 3, times the height of 1. For a sphere, it is 4/3 times pi, you're not going to use that, times the radius cubed, which in this case is 3 cubed. And then you're going to subtract, and that'll be your answer. Number 11, this is Pythagorean theorem. You're going to draw it out. They've actually drawn it in there for you. So remember that a squared plus b squared is equal to c squared. And then at the very end, don't forget to do the square root of c squared, or whatever that answer is. Number 12, drag and drop. You want terminating. Terminating means to end. Repeating means not to. Type these into calculators. Find out, do they repeat? Do they not repeat? Simplify. This is just solve the equation and stuff. Do the best you can there. We've done this a bunch this year. And then this one is, how many solutions does it have? You should be able to answer that based on the video from yesterday. And then this one here, it wants you to graph and use whichever one you got to use. So if you think it's this one, you're going to set it up here. So we'll click here, click on that, and see, oh, it goes the whole way that way. If it's not, it's not. You can click reset and it'll redo it. If you have questions, feel free to email me. I will help you the best I can. And then don't forget to click submit.